Hello, mathematicians. Today we're going to be learning about systems of equations using elimination. And elimination is most commonly used when we have standard form. So here we have 5x minus 4y is equal to negative 4, and we have negative 5x plus 6y is equal to negative 4. So when we do use elimination, we want to make sure that two of our coefficients that are in front of the same variable are opposites. So either 5 and negative 5 or negative 4 and positive 6. So we know that negative 4 and positive 6 are not opposites, but 5 and negative 5 are. And so because they're opposites, we're going to treat this like an addition problem and add straight down. So 5 and negative 5 is 0x, so that just cancels out. And negative 4y plus 6y, we end up with 2y is equal to negative 4 and negative 4 is negative 8. So 2y is equal to negative 8. In order to get y by itself, we divide both sides by 2. So we end up with y is equal to negative 4. So using elimination, now we solved for one of the variables for when they intersect. So they intersect when y is equal to negative 4. So now all we'd have to do is find the x value that they intersect at. So if we rewrite our equations, 5x minus 4y is equal to negative 4, and negative 5x plus 6y is equal to negative 4. We're going to substitute y in for negative 4. So 5x minus 4 times negative 4 is equal to negative 4. And so negative 4 times negative 4 is positive 16. So 5x plus 16 is equal to negative 4. So then we'd subtract both sides by 16. 5x is equal to negative 20. If we divide both sides by 5, we get x is equal to negative 4. And so let's solve over here and see if we get the same thing. So we have negative 5x plus 6 times negative 4 is equal to negative 4. So we have negative 5x, and we have positive 6 times negative 4, which is negative 24, is equal to negative 4. So we add 24 on both sides. And we end up with negative 5x is equal to 20. And in order to get x by itself, we're going to divide both sides by negative 5. And x is equal to negative 4. All right, so these two lines meet at one point, and that one point is at negative 4, negative 4. Okay, so here we have another example, and we need to make sure that the coefficient either in front of x are opposites or the coefficient in front of y are opposites. So here we have negative 1 and negative 1, those are not opposites, and we have 5 and 5, and those are not opposites. So what we could do is we could take one of these equations, and so for example the second one, and I can multiply that by negative 1. So now our first equation is still negative x plus 5y is equal to negative 4. But now our second equation would be, so negative 1 times negative 1 is positive 1x And then negative 1 times 5y is negative 5y. And then negative 1 times 2 is negative 2. So now we have opposites. So negative x and x, those cancel each other out. So that's 0. And then I have positive 5y, negative 5y, that's 0. So 0 is equal to negative 4, negative 2, that's negative 6. So 0 is equal to negative 6. And now, since we know that this is not true, these two lines are not going to intersect, and therefore this has no solution. Okay, so there's no x and y value that will make both of these true, and these lines will not intersect. Okay, so here we have another one, and again, we don't have opposite x values, well, opposite coefficients for our x, and we don't have opposite coefficients for a y. So we could take either or and multiply it. So I could actually take this first equation and multiply it by 2, because if I multiply 3y by 2, I would get positive 6y. So if I multiply that by 2, I end up with negative 12x plus 6y is equal to, and now I also have to multiply the 2 times the 15, so equal to 30. And then our second equation, I could just rewrite negative x minus 6y is equal to negative 17. So now we could combine these. So negative 12x minus x is negative 13x. Positive and negative, those two cancel out, so they're equal to 0. And now I have 30 minus 17, and that's equal to 13. So I have negative 13x is equal to 13. So if I want to solve for x, I'd have to divide both sides by negative 13. And so x is equal to negative 1. And now, since I know that they do intersect where x is equal to negative 1, I have to go back and substitute these two equations for negative 1 wherever I see an x. So I'm going to rewrite those two equations. So negative 6x plus 3y is equal to 15, and I have negative x minus 6y is equal to negative 17, and I'm going to substitute them both in for where x is going to be equal to negative 1. So negative 6 times negative 1 plus 3y is equal to 15. And then here I have, so a negative times negative 1 minus 6y is equal to negative 17. So negative 6 times negative 1 is positive 6, plus 3y is equal to 15. Subtract both sides by 6. So 3y is equal to 15 minus 6, which is 9. And divide both sides by 3. And so y is equal to 3. And then here I have negative times negative 1, which is positive 1, minus 6y is equal to negative 17. So I subtract by 1 on both sides. And so negative 6y is equal to negative 18. Divide both sides by negative 6 to get y by itself. And so y is equal to 3. So these two lines do intersect at one point, and that one point is negative 1, 3. All right, so here I have another set. I have 2x plus 10y is equal to negative 16, and I have 4x plus 5y is equal to negative 2. So it really doesn't matter which one you multiply. I could either multiply my first equation by negative 2 so that I'd get negative 4x and positive 4x, or I could multiply my second equation by negative 2 so that I'd get 10y and negative 10y. Okay, so I'll multiply my second equation by negative 2. And so I end up with 2x plus 10y is equal to negative 16 because we're not changing that. And then I end up with negative 8x minus 10y, and then I have to multiply the negative 2 also by negative 2. Sorry. That equals 4. And so we have positive 2x minus 8x, which is negative 6x. These two cancel out, and then I have negative 16 plus 4, which is equal to negative 12. And if I want to get x by itself, I have to divide both sides by negative 6. So we know that x is equal to negative 12 divided by negative 6, which is positive 2. So we're going to rewrite each equation and substitute the x for 2. So 2 times 2 plus 10y is equal to negative 16. And here we have 4 times 2 plus 5y is equal to negative 2. And so we end up with 2 times 2, which is 4, plus 10y is equal to negative 16. Subtract both sides by 4. So 10y is equal to negative 20. And here we have, so if we want to get y by itself, we have to divide both sides by 10. So y is equal to negative 2. And here we have 4 times 2, which is 8, plus 5y is equal to negative 2. So we subtract both sides by 8. Leaving us with 5y is equal to negative 10. If we divide both sides by 5, we end up with y is equal to negative 2. And so these two lines meet at one point, and that one point is 2, negative 2. And that's it. And so here we have another example. 6x minus 18y is equal to negative 12, and 8x minus 24y is equal to negative 16. So again, we're going to have opposite coefficients. And since there's no number I could really multiply the first equation by to get an opposite here, or the second equation to get an opposite here, I actually have to multiply both of them. So I know that the least common multiple between 6 and 8 is 24. So I can multiply this one by 4 to get the coefficient for x to be 24. And I can multiply the second equation by negative 3 so that I could get a coefficient of negative 24. So I end up with 24x, and then I have negative 18 times 4, and that's negative 72y. Then I have to multiply the 4 times the negative 12. So if I multiply those two, I get negative 48. And then for my second equation, I have to do negative 3 times 8, which is negative 24x. And then negative 3 times 24, which is positive 72. And then I'm going to also have to multiply negative 3 times negative 16, which is positive 48. And so if I combine these, positive 24x minus 24x is 0. So those cancel out. And then negative 72 plus 72y is 0. So 0 is equal to negative 48 plus 48 is 0. So here, any number I substitute in for x and y will work. These two are infinitely many solutions because they're the same equation. So here I have infinitely many solutions. All right, and that leaves us to our last example. So same thing here, there's no number that I can multiply just one equation by, so I'm going to have to multiply both equations. And as we mentioned before, the least common multiple between 8 and 6 is 24. So here, I could actually multiply this one by positive 3. And this one I'd have to multiply by negative 4 so that they could be opposites. So 3 times negative 8 is negative 24x. 3 times negative 24 is negative 72y. And then 3 times 3 is 9. And then here I have negative 4 times negative 6, which is 24x. And then I have negative 4 times negative 18, which is positive 72y, is equal to, now I have negative 4 times 0, and that's just 0. So if I go ahead and combine these, negative 24 and positive 24x is 0. They cancel each other out. Negative 72 and positive 72y cancel each other out. So that's 0 is equal to 9 and 0 together is 9, and since 0 is not equal to 9, we have no solutions here. And just to go over what if infinitely many solutions means, here our two lines are exactly the same, so they will intersect at every point. And here when we have no solutions, our two lines are parallel, so therefore they will never meet at any point.